This video will cover transformations off the grid in geometry. So here we're given a figure where we have triangle ABC, which ends up getting mapped onto triangle A double prime B double prime C double prime. And we are asked to identify the sequence of transformations that maps A, B, C onto A double prime B double prime C double prime. And so here you can see when it says a sequence of transformations, that means two or more transformations, 2 plus. So here I'm going to think about how I could transform this original given triangle such that it maps onto this new triangle, the double primes. And so I'm thinking and I'm looking at those two triangles and it looks like they're moved away from each other. And so if I think of my keywords like flip, slide, and turn, these kinds of words will really help us with these transformations off of the grid. So you can see that the triangle was kind of slid over. So a slide means a transformation. If I try and slide this triangle ABC over so that it maps onto point C double prime and A double prime, B prime would be down here, A prime right where A is, or A double prime is, and C prime right where C double prime is. So we can call this a translation, capital T, on vector A double prime. And again, that word I just used was vector. A vector is just used when we use a translation, and the symbol looks like that. It just means that we move in a certain direction and length. So it tells us which way to move and then for how far. So here we want to move towards the right, taking A and mapping it onto A double prime. So translation on vector A double prime was our first step. Then if I look at the triangles again, I notice that they look like they're flipped. B prime is currently down here at the bottom of my picture, but I need to get it all the way up to the top of my picture. So a flip is called a reflection. That's that lowercase r. And I'm trying to decide what do I want to reflect over. Do I want to reflect over a segment such as AB, a segment of the triangle, or this horizontal line here, XY? And if I were to reflect over XY, B is some distance away, and if I count that same exact distance, it ends up being mapped to B double prime. So here I can say that this is a reflection over X, Y, the segment. So here we have finished our final answer. If you wanted to write it out in composition notation, remember that's where we have blank composed with blank, where the first thing is done on the right, the second transformation is done on the left. We could write it in this notation where we put the translation on vector A double prime, which was composed with the reflection over segment XY. Either answer would be acceptable as long as you get the notation correct and in the correct order for number 1. When we look down here at number 2, it looks like it's the same problem, so we're going to adjust it just slightly so that it's a different picture. And so just check back in with me in a second so that you can get your picture adjusted like mine. Okay, so I've redrawn a picture and I want you to draw something similar to yours on your paper so that we have a different problem to work with here. As you can see, I just kind of covered up or scribbled out the original A double prime, B double prime, C double prime triangle, and I drew a new one over here in pink. So start by just drawing a regular right triangle where A double prime is located down at the right angle, C double prime is that lower right angle, and B double prime is that top vertex, that top angle. Once you have that drawn on your paper, then check back in with me. Okay, so we are asked to identify the transformations that maps one triangle onto the other. And so here again, it looks like the triangle is slid over. So I'm going to start by sliding the triangle on vector A double prime. So then my new triangle, my new image, will look something like this, where C prime gets moved here, A prime lands on top of A double prime, and B prime comes down here. So that again was the translation on vector A double prime. Now in the previous example, we could have translated on any vector that we would have wanted to, such as C double prime, because that whole triangle was getting moved over. Let me see if I can show you here. So again, I could have translated on C, C double prime, or A double prime, because that whole triangle was getting shifted over. Whereas if we look down here in this second example, let's get this lined up again. I would not have wanted to translate on C, C double prime because it would have brought me too far. A prime would have landed way over here, and that's not where I wanted it to be. I wanted it to be right on A double prime because my next step is going to utilize A double prime. So here it looks like maybe I could reflect the triangle, but if I reflected, C would still stay way out here, C prime. So I'm going to try turning or rotating my triangle. If I go from a quadrant 3 down here and rotate upwards to quadrant 1, that's a rotation of 180 degrees if we were on a grid. Well, we can still rotate 180 degrees off of the grid, but we have to be a little bit more specific. When we're on the grid, we always rotate around the origin. When we're off the grid, we have to identify the point at which we're rotating around. And so here, that's why I wanted to translate to A double prime so that we could rotate around that single point. So our final answer is translation on A double prime and a rotation around A double prime of 180 degrees. In example 3, we are given square MNOP, where lines are drawn through the square in order to create congruent triangles. Our first step is to determine a transformation that would map triangle TAN onto triangle TAO. So here it looks as though T and A stay in the same position, but N gets mapped over here onto O. And so this to me is a reflection, and then I have to decide what I'm reflecting over. What is the consistent line that stays the same? And so here I can see that I reflected over segment RT. The next part says if MAQ is transformed by rotation around point A of 90 degrees, state the image. When it asks for image, it wants the new triangle. Where does it land? So here if I take this red triangle MAQ and I rotate 90 degrees, remember positive degree rotation means move counterclockwise, so rotate the triangle down towards the left. So if I rotate around A, that means A stays stationary. And if I rotate 90 degrees, this angle Q is now going to map onto T. Swing it 90 degrees and it maps to T. So now my triangle becomes NAT. And notice the order that I wrote the letters in. M gets mapped to N, M gets mapped to N, A stays the same, so A stays the same, and Q gets mapped to T. Remember that Q kind of looks like a right angle, and so does T, and so Q gets swung around or turned around to map onto T. Go ahead and try your practice problems. Remember, you can rewind the video if you need to. Check back in with me.